12 equals 4. And it goes out 5.3, so it should look like this at the top of your page. By definition, a rectangle is a quadrilateral with how many right angles? 4. All their angles are right angles every time. And mark that. So any figure that has 4 right angles is a rectangle. Any figure. 4 right angles is a rectangle. Right? And we also know a rectangle is a type of parallelogram. So any property that we talked about parallelograms also applies to rectangles. So what do we know about parallelograms? We know they're opposite sides. They're equal and they're also parallel. Same thing with rectangles. This side is equal to this side. This side is equal to that side. And they're also parallel to each other, just like a parallelogram. What else do we know about parallelograms? We know about their opposite angles. So what? Their opposite angles are the same. If you notice in the diagram, that's still true. They're the same. They're both 90. What do we know about the angles that are next to each other? They what? They add to 180. And you know 90 plus 90 equals 180. So that still holds true. What do we know about the diagonals of a parallelogram? If we were to draw in these diagonals, what do we know about those? Very good. They bisect each other, which means this piece and this piece are the same, and this piece and that piece are the same. Cut each other in half. So those important properties of parallelograms also apply to rectangles. You can use those as well. 2 new things about rectangles, and they only apply to rectangles. They do not apply to all parallelograms, only rectangles. Right? Again, we know by definition all 4 angles are right angles. That only applies to rectangles, not all parallelograms. Okay? One new thing is the diagonals are congruent. That's only in rectangles. Not all parallelograms have the same diagonals. If it's a rectangle, you know the diagonals are the same, which means that AC is congruent to BD. We know those rectangles, those diagonals are congruent. This distance is the same as that distance. But because they're the same and they're bisecting each other, all 4 of these little pieces are also the same. Because they're bisecting each other, they're the same distance, so these pieces are also the same. That's only true for rectangles, not all parallelograms. So know it is. Okay, questions over that?
All right, let's try some practice here. Talk about our old friend, the rectangle. So quadrilateral LM and P is a rectangle. Find the measured angle M and L. All right, cool. Who's got an idea? Based on this information, who's got a plan to solve for this angle? Help me see where that angle's at. I'm going to highlight it. It's right hither. There it is. So we're looking for this angle. Who's got an idea? Yes, you. I could say that. Now, why can you say that happens? What's your reasoning? You're right. They are alternate here, so I know their measures are exactly the same. Very good. But the problem is, what? What's the issue with this, Shane? They're 2 different variables. You're exactly right. I've got a y, I've got an x. They are equal, but I can't set them equal because I have 2 variables. So what do we do? Well, we always try to find the variables that are like. Is there anything that's matched up? Jacob, what we got? Very good. These two angles, the one's the x of 5x plus 8 and the 3x plus 2, they are side by side. And since we know this is a rectangle, the definition of rectangle means that they have right angles. So there is a right angle right there. So you're exactly right. So together, I know those equal how many degrees? 90. So I'm going to say that 5x plus 8 plus 3x plus 2 is equal to 90. And we know this step, once I write down the equation, my next step is always going to be combining like terms, kind of smush the things together that match up to one another. So I'm going to say these x's go together, these numbers go together. So let's get them together here. 5 and 3 gives me 8x. 8 and 2 give me a 10 equals 90. Look what we got. An infamous bear problem. Start solidifying here. What do you want to do first? What do we got? What's that? Subtract 10 minus 10, he gone. 8x is equal to 80. Uh-oh. That's pretty nice. You know we're going to divide by. X equals 10. Cross that 0 off. We got a 1 there. Add it back on. All right, nice. Done. We are all done. Right? I'm done. I solved it. I'm done. Can't do it. I am not done. Because does it say find x? No. It says find m and l. All right, well, how do I do that? Oh, do I take this x and plug it up here, this angle? Can I do that? Why can't I do that? Why can't I, what? Why can't I do this? Two different variables, not going to work out for me. That's a bad idea. What we got there? Why am I allowed to do that? Why can I put this for that? Yeah, because what kind of angles are those two? You're right. They are what? Oh gosh, now here comes the memory. They're on different sides of the line. They're alternate interior. Alternate interior angles are congruent. So let's figure out this angle. What this angle is at 3x plus 2, and then we'll know what that angle is. All right, let's go for it. So my angle is 3x plus 2. That's a plus, by the way. So 3x plus 2, figure out what that is. Well, I know that the x is a 10. So I'm going to do 3 times 10 plus 2. 3 times 10 gives me a 30 plus 2. So 30 plus 2 gives me a 37. Oh, yeah, as well. 32. All right. 32. Great. So now that I know that angle's 32, I also know the other angle's 32 because they are alternate interior angles. So now my final thing is I can say that the measure of M and, that's not an N, measure of M and L is equal to 32 degrees. Question of those? Pretty easy. We've done it before, stuff like this. Again, a lot of this rectangle stuff looks familiar, like we've done it before, because we have. Again, add two things up, 7 equals 90. All right, get ready for it. I hope you guys are sitting down for this next one. Our old friend, Mr. Proof.
Again, these proofs are just like those triangle proofs we talked about in Unit 2. So go ahead and make your 2 columns. You have your statements. And your reasons. What's our first reason every single time? And what is our first statement? Yeah, that's information given to us. I'm going to abbreviate rectangle by just drawing one. W, X, Y, Z with diagonal WY and ZX. What's going to be our last statement? We just don't know what number it is. What's our last statement? We just don't know what number it is. Let's see. Yeah, what we're trying to prove. So in this case, it's WY is congruent to ZX. Fill in your vote. What else should we probably do? Wasn't given to us. It's really helpful if we have one. Yeah, diagram. So if you don't have your diagram, draw it. So we know we have a rectangle. We can draw a rectangle. We can cheat and draw a really nice one. Okay. And we know our rectangle has diagonals, so we're also going to draw those in. And then label the vertices. W, X, Y, and Z. It looks something like that. So essentially what we're doing is we're doing those triangle proofs. So we have to prove that two triangles are congruent. We have to make sure that these triangles have both of these diagonals, because that's our goal, to say that those diagonals are congruent. So we're trying to ultimately prove that this triangle and this triangle are congruent. Those two triangles have both of those diagonals in them. So notice how everything's kind of smashed together in one picture? It's also going to be super helpful if you redraw those triangles exactly how they are. So again, we can cheat and drag them, but redraw them. So that way they're separate and you can kind of visualize everything much better. So I would go ahead and redraw them.
Oriented the same way. Don't turn them around.
And keep those vertices the same. Redraw them like that. I'm going to re-highlight them so we can see it a little bit better. When we talk about things regarding these triangles. Alright, well we know we have a rectangle. What do we know about all the angles of a rectangle by definition? What do we know? What are all four angles of a rectangle? They're what? They're all right angles. So we know this angle right here is 90 degrees, this guy's 90, this guy's 90, that guy's 90. So then, you notice this whole angle, this big angle of W has the right angle, so that angle is also going to have a right angle. Notice the blue triangle, this angle Z has a right angle, so in your diagram it's also going to have a right angle. But we can state that in the next step of our proof. We can say angle XWZ and angle YZW are right angles. Because we know it's a triangle. So think of that kind of shortcut. In our statement, we're talking about a rectangle. So you know our next reason is going to be definition of a rectangle.
The vocab word.
There's one piece. Got an angle. Well, what do we know about right angles? We're going to kind of lump this together. If they're both 90 degrees, we can say that those two angles are
Who's card speaking?
congruent. If they're both 90, then we know angle XWZ is congruent to angle YZW because they're both 90. And we've had this before. If you make a statement of two angles are right angles, your very next reason is going to be all right angles are congruent. All right angles are congruent. It's a little different than what we've done in the past, but if you look at their diagram, not the triangles, and looking at the triangles might help. But what do you notice? Are they sharing anything? Are they sharing anything in that diagram? No? No, because they're sharing anything? Cindy? sharing this side WZ, if you notice in the diagram, the colors overlap. And if you notice in your triangles, they're the same. So if they're ever sharing a side, what's our reason going to be? Every time they're sharing a side, our reason is reflexive property. And then you just state that that shared side is congruent to itself. Nothing is flipped. I guess it kind of is. So YZ, WZ is congruent to CW. We'll mark it. We just said that that shared side is congruent to itself. There we go. We have two pieces. We just need a third piece. Well, what do we know about rectangles? They're also what? Rectangle is a type of, talked about at the beginning, parallelogram. Well, what do we know about the opposite sides of parallelograms? They're congruent. So because we know it's a rectangle, we know it's a parallelogram. And we also know in parallelograms that those opposite sides are congruent. So then we know that this side and this side are the same. And those are also parts of our triangles. So in your next step, you can say that XW is congruent to YZ. Because it's a parallelogram. Definition of parallelogram. Do we have all three pieces? To say that these triangles are congruent? Yeah, what three pieces do we have?
Let's try the shortcuts. Which one is it?
Side, angle, side. Yeah, we have a side, we have an angle, we have a side. So we can say that these triangles are congruent by side, angle, side. And it's really nice, we wrote up here in this step that those two angles were congruent. So you literally just write the same thing but use a triangle symbol instead. Well, once you say that the triangles are congruent, you can prove that their parts are congruent. And what's our reason when we prove the triangles are congruent, then you say the parts are congruent, that reason every time is C, B, C, 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 and done. Questions over that? You're going to have that hard of a one on your test. I don't even think there's that hard of a one on the practice. But they're good to see these, four of them together. Just so saying, prove the triangles are congruent, you might be done, or you might have to prove the triangles are congruent, then prove their parts. Just like what we did in Unit 2.